Mr. Prasoon Bandyopadhyay. He's an architect with 6 years of experience in IT parks, institutional spaces and retail design. He graduated in the year 2011 from National Institute of Technology, Patna. He joined L&T Construction in 2011 and worked in various multi-million projects spanning from various IT parks to institutional spaces. Presently, he serves as a lead architect at Future Research Design Company.
Welcome to UGC lecture series. I am taking construction technology AR6013. This is the lecture 02. So this is the unit 1 construction systems. In this lecture we would go through reinforced cement concrete structures, the concept of pre-stressed concrete, the concept of precast concrete, the prefabrication system of construction and the modularity in construction. So what are reinforcement cement concrete structures? In my last lecture I have described about various structures and what are cement concrete structures and structures with different materials. So reinforcement cement concrete structures are nothing but structures or structural elements made up of concrete, reinforced concrete. For the cement concrete structures there is an important concept of pre-stressed concrete. So pre-stressed concrete is a method for overcoming concrete's natural weakness in tension. Like any other material, concrete also is a material that has many weaknesses. The most significant weakness of all is its natural weakness in tension. So when it is subjected to tension, it fails after a certain extent. So pre-stressed concrete is done pre-stressing is done to overcome this weakness in tension. It can be used to produce beams, floors or bridges with a longer span than is practical with ordinary reinforced concrete. So there are two methods of introducing pre-stressing to a concrete. One is pre-tensioning, the other one is post-tensioning. As I said, materials like concrete will shrink while curing and it can also suffer sectional losses due to creep when subjected to pressure. The amount of shrinkage and creep likely to occur can be controlled by designing the strength and workability of the concrete. The essence of pre-stressed concrete is that once the initial compression has been applied, the resulting material has the characteristics of high strength concrete when subject to any subsequent compression forces, and of ductile high strength steel when subject to tension forces. So this can result in improved structural capacity or serviceability as compared to other conventional reinforced concrete in many situations. Tendons. How do we do it? We do pre-tensioning or post-tensioning, basically the parts of pre-stressing, with the help of tendons. So tendons can be defined as small diameter wires, those are 2 to 7 millimeters, in a plain, round, crimped or indented format. These wires may be individual or grouped to form cables. The two main advantages of strands are, first of all, a large pre-stressing force can be provided over a restricted area, and secondly, strand can be supplied in long flexible lengths capable of being stored on drums, thus saving site storage and site fabrication space. As you can see in the slide here, these are the typical tendon formats. In this particular figure, we can see there are 12 number 7 millimeter diameter wires that are stressed together, and this is combined by a binding tape. So this is also called a parallel lay cable. So all these wires, they form a cable structure. Second is a monostrand cable. In this, we are using 15 millimeter diameter strands which are 7 in numbers. So these are strongly stressed and they form a single strand. This particular illustration is an illustration of a monogroup cable. So these are 13 numbers 15 millimeter diameter strands which are stressed together. So these are strands. The collection of these cables, they make tendons. So these tendons help us in pre-tensioning or post-tensioning. Next is the concept of pre-tensioned concrete. Pre-tensioned concrete is a variant of pre-stressed concrete where the tendons are tensioned prior to the concrete being cast. The concrete bonds to the tendon as it cures, following which the end anchoring of the tendons is released and the tendon tension forces are transferred to the concrete as compression by static friction. In this illustration, you can see this is a tendon that is joined by two ends. The other end we can see a hydraulic jack here, which gives the tension forces to the tendons. In pre-tension concrete, what we generally do, the basic intent is to have these strands put together and we apply tension from one side. So these strands are stretched and after that we pour concrete over it. So this is the basic intent of pre-tension concrete. You can see here in this illustration, as the strands are stretched, after that the concrete is cast around the stretched wires. We can put dividing plate or spacer as required. See, in this case, this is a hydraulic jack to give tension forces to the tendons and to stretch it. And this is an anchoring done at the other end. This is a typical example of how we do pre-tensioning. This is a pre-tension slab casting picture. In this we can see these are the tendons that are stretched at both the ends. One side is fixed and the other side is pulled, and it is stretched and properly formed, and then after that we pour concrete over it, thus forming a pre-tensioned concrete. So now coming to the concept of post-tensioned concrete. Post-tensioned concrete is nothing but a variant of pre-stressed concrete where the tendons are tensioned after the surrounding concrete structures has been cast. The stressing is carried out after the concrete has cured by means of hydraulic jacks operated from one or both the ends of the member. In this case, we can see this is a concrete element and we see that a strand is passing through it. So this strand is put inside this concrete element. After the casting and placing of the concrete, we put these strands when we tension it either from both sides or from one end. We can see the anchorage housed in recess filled with stiff mortar here on this side. This side there is hydraulic jack, and here this is called a grout filled duct, and this is the pre-stressing tendon helical reinforcement. This is a typical example, an illustration of how a post-tension concrete structure looks during erection. These are the typical anchorage details for the tendons. You can see this is a male cone that is driven into the female cone. These are the tensile steel spiral to hole that holds it together. This is the reinforced concrete female cone that is cast into end of concrete member, as I already explained in the earlier slides. This is called the grout hole as shown in the earlier illustrations. This is a forged steel anchorage block. These are the holes to support to take the tendons in. As I said, these are the 7 number holes for strands and jaws. These are the fixing holes. This is a socket for steel duct, or it is also called sheath. This is a malleable cast iron anchorage and bearing plate cast into the end member. These are the grout holes, as I explained earlier. The comparison of pre-stressed concrete with reinforced structures. So when comparing pre-stressed concrete with conventional reinforced concrete structures, the main advantages and disadvantages can be enumerated, but in the final analysis, each structure and components must be decided on its own merit. The main advantages: number 1, it makes full use of the inherent compressive strength of concrete. Number 2, it makes full use of the special alloy steels used to form pre-stressing tendons. Number 3, it eliminates tension, cracks, thus reducing the risk of corrosion of steel components. Number 4, it reduces shear stress. Number 5, for any given span and loading condition, a component with a smaller cross section can be used, thus giving a reduction in weight. Number 6, individual precast concrete units can be joined together to form a composite member. There are disadvantages also. The main disadvantages are: number 1, high degree of control over materials are required. So the design and quality of workmanship is required to a great deal. The special alloy steels are dearer than most traditional steels used in reinforced concrete. Number 3, extra cost of special equipment are required to carry out the pre-stressing activities. And number 4, cost of extra safety requirements are needed while stressing the tendons. As a general comparison between the two structural options under consideration, it is usually found that up to 6 meter span traditional reinforcement concrete is most economical method. But for spans between 6 meters to 9 meters, the two cost options are somewhat comparable. But for spans over 9 meter, pre-stressed concrete is definitely more economical than reinforced concrete, because the span is too high. It's always better for the application of pre-stressed concrete. It should be noted that generally columns and walls do not need pre-stressing, but in tall columns and high retaining walls where the bending stresses are high, pre-stressing techniques can sometimes be economically applied. Coming to the next section, it's precast concrete. Precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment. These structures, which are cured in a controlled environment and molded to particular shape, are then transported to the construction site and lifted it into the place. In contrast, standard concrete is poured into site specific forms and cured on site. So the basic idea is that there is an assembly line and there are molds, and we are pouring concrete into the molds, curing there at some other location, transporting the particular form of concrete to the site, and lifting and placing it up as required. And why do we use precast concrete? First of all, precast concrete structures are very comfortable. The material has intrinsic properties of thermal inertia, allowing a more constant temperature both in cold and hot regions, and also acoustic insulation. So we can actually control how much it will expand and contract as per the location where the structure is getting built to. Secondly, the precast concrete is safe. Not only is the structural stability maintained for longer periods, but concrete construction prevents the spread of the fire from one building to another. It is sufficiently strong to resist impacts, blasts, and natural catastrophes like earthquake, tornadoes, and floods. Precast concrete is versatile. Factory production allows a wide choice of surface finishing, color range, and special shapes. Precast concrete has another advantage: its moldability, which entails designers to copy classic details like keystones and capitals or match the finish of materials like weather stones, etc. The precast concrete industry can source a wide range of aggregates locally and offer a tremendous variety of colors and visual effects. So a precast concrete is very useful for designers. So we can use the surfaces we want, we can use the textures we want, we can use the color we want, and we can have applications at various locations, not only as a structural member but also as a finishing material. Precast concrete is healthy. In today's case, indoor air quality is a prime concern for all of us. So the precast concrete is stable throughout its life, and it does not need chemical treatment to protect it against rot and insect attack. So this means that there are no emissions in the internal environment at all. Precast concrete is optimized. Advanced technologies used in the precast plants create an improved quality product, that is, reduced tolerances, thinner sections, engineered solutions compared with cast on site concrete. What happens is, at site, when we do cast in situ construction, in most of the cases, due to workmanship error, we do not get finished edges. So when we do application of precast concrete, a precast concrete product can be corrected to even plus minus 0.00. So additionally, this quality can be checked before a unit is inserted into the structure or site work. So we can actually check the tolerance of the particular product, and then we can apply it on the wherever the application is required. So precast concrete is useful for that. Plus also precast concrete undergoes a lot of quality checking before it reaches the site. So it's always a boon to use precast concrete for various applications. Precast concrete is durable. We all know that concrete lasts for years. Egyptians and Chinese people used an ancient form of concrete for buildings and structures that still exists today. Concrete is used where the structural stability has to be maintained for long periods. Effective design detailing helps to lengthen the life of a concrete building. Precast manufacturers can offer guidance on designing for durability. Precast concrete is ecological. Precast concrete is made up of natural raw materials, that are stones, gravels, sand, cement, etc., which are locally available almost everywhere and in enormous quantity. Precast concrete minimizes the whole life cycle impact of the environment when compared with other construction, because precast concrete units can entirely be reused or recycled. Precast concrete is fast. The top floor of a skyscraper, for example, can be cast in the factory when the foundations have not yet been started. In a typical construction for a skyscraper, to go from foundation to the top floor will take ages, whereas in a precast construction, what we can do is, when the foundation is still on site, we can cast the floor in some factory and we can bring it to the site, and then we can place it as and where we want. But the project requirements of a modern construction prefers an in-time delivery, as I was saying. On-site construction using precast concrete is not only faster but also safer, as secure working platforms are quickly established. Precast concrete is also affordable. Precast concrete combines the excellent quality of factory production with a relatively inexpensive material. The costs of repair and maintaining a concrete structure are highly limited. Therefore, no need to compromise on quality to reduce costs. Simply choose the best way to use locally available resources. Precast concrete is also sustainable. Sustainable means a three-win situation for the three pillars of a society: people, profit, and the planet. If only one of these elements is negative, the solution can't be affordable and sustainable. Here in this illustration, I bring to you examples of precast concrete. In this figure, you can see a section of the staircase which is completely precast in a factory, brought to site and assembled. You see, this is a picture on the right hand side of a factory which does precast modules for construction. So, these are all precast modules with holes or insertions which are brought to site and inserted wherever is required. It is a male female joint concept. So, we can bring these, we can transport these modules to site and fit to the applicable spaces as and when required. Prefabrication system. Prefabrication system is the practice of assembling components of a structure in a factory or other manufacturing site and transporting complete assemblies or sub-assemblies to the construction site where the structure is to be located. I just spoke about precast concrete. Prefabrication system is an extension of precast concrete. What we do is, what I explained to you about the precast concrete system, prefabrication is an extensive combination of those precast elements. For example, the summary of the entire prefabrication thing, a definition is, for example, if I have to make a house, what I do is, in a factory or a warehouse, I assemble the entire, maybe half full or 25% of a house, including staircases, that may include walls, that may include doors, that may include floor slabs, that may include roof slab, and then transport the entire unit to the site and fix it as per the site conditions. The salient features of such construction technique: the assembly of buildings or their components at a location can be done other than the building site. This method controls construction costs by reducing on time, wages and materials. Prefabricated units may include doors, stairs, window, walls, wall panels, floor panels, roof trusses, room sized components and even the entire buildings. The term prefabrication is used to distinguish this process from more conventional construction practices of transporting the basic material to the construction site where all the assembly is carried out. Advantages of prefabrication system: first of all, we get a high quality product without any error. Second, we get related savings, we get considerable savings related to labor costs. Third, we get savings in time. Fourth, we have an overall efficiency which is greatly increased. Fifth, mass production is easier and quick. Protected and controlled production environment. Next, potential for lower production costs and other cost savings. Independence of climatic conditions. The disruption of traffic is avoided, and it also ensures high degree of safety. Disadvantages of prefabrication system: we have to carefully handle the prefabricated components such as concrete panels, steel or glass panels when we have to transport from the factory or the warehouse to the site. Attention has to be paid to the strength and corrosion resistance of the joining of prefabricated sections to avoid failure of the joint. Not only that, the joints once placed at certain points, we also have to ensure that it is watertight. So, all this requires a lot of attention and detail. The leaks can form at joints in prefabricated components. Transportation costs may be higher for voluminous prefabricated sections than for the materials of which they are made. For example, concrete might be easier to transport other than giant sections of, for say, a girder, an RC girder, a huge girder for a bridge. Large prefabricated sections require heavy duty cranes, as I just explained, and precision measurements and handling to place in position, because nowadays we even use GPS system to construct the metro lines, the metro girders, the bridges. So, we require a high degree of precision to prefabricate such members of concrete. Here I bring you few illustrations of prefabrication system. In this left picture, you can see that this is a wall getting built for a building, and this element is a prefabricated element. So, these are like modules. You know, a module contains 3 units. You can see here it's an RC wall, which also includes 3 divisions, 3 windows, and including mullions and glasses, etc. So, each of this component is manufactured at site or fabricated is manufactured in the factory or fabricated at the factory and is brought into site and assembled like a jigsaw puzzle. In the right illustration, you can see an entire part of a floor getting prefabricated at site, brought to site by a heavy duty vehicle and lifted by a heavy duty crane and put into place. The concept of modularity. What are modular buildings? Modular buildings and modular homes are sectional prefabricated buildings or houses that consist of multiple sections called modules. Modular is a method of construction differing from other methods of building, like the conventional ones. Modular components are typically constructed indoors on assembly line. Modules construction may take as little as 10 days, but more often 1 to 3 months. Completed modules are then transported to the building site and assembled by a crane. Placement of modules may take from several hours to several days. As I explained prefabrication system, modularity is just an extension of the prefabrication system. In modular buildings, what we do, for example, an entire floor or an entire building is prefabricated at site, brought to site, and then it is constructed or it is placed into position. In these illustrations, you can see a floor is getting constructed at the site, a staircase is getting done, all the walls are getting erected at site. So, this is an example of perfect modularity. A perfect floor along with its components are constructed in a warehouse, which will be further shipped to the site and will be lifted by a heavy duty crane to its particular position. In this illustration, you can see we are constructing a roof, we are constructing a roof in modules. So, this is a roof piece which is set in place, so which will be further taken to site and fixed at its appropriate location. When we are doing modular buildings, a construction is just a repetition of these modules. So, these modules are fixed, prefabricated, we have a certain set of dimensions. In construction, what we do, we have a repetition of this. For example, if a module dimension is has a square feet area of x, say, at the site we will have for example a multiple of 2x, 4x. So, it is always a repetition of these modules. So, to summarize the entire lecture, first of all we learnt about reinforced cement concrete structures. We also learnt about the concept of pre-stressing, which includes the concept of pre-tensioning and post-tensioning. We learnt about the strands, we learnt about the tendons, we learned about how pre-tensioning and post-tensioning stabilizes and reduces the weakness in concrete. We understood the concept of prefabricated structures, and we also understood the concept of modular buildings and importance of it in the construction industry. The questions: write a note about reinforced cement concrete structures, explain in detail the concepts of pre-stressing, explain the concept of prefabrication system of construction, explain the concept of modularity in construction. Thank you.